Hey, good morning. Today we continue with more problems involving integrals. So we'll be integrating some functions. And remember, when we're integrating, we are just reversing differentiation. So when we get our answer and we differentiate it, we should get back to the original function that we were asked to integrate. So we continue with this is exercise, I think 13.2. Okay, let's see, this is number 7. So what we have to integrate is ln of x over x dx. Now the integration that we've been doing lately has been has involved substitution, where if you see a function with its derivative, what you do is you let your function equal to u, and then the derivative will get swallowed up in a way with the derivative of the function. So here you can look at this as the integral of ln of x times 1 over x dx. So I know that the derivative of ln of x is 1 over x, so I can let u equal to ln of x. Now if u is equal to ln of x, this means that du is equal to 1 over x dx. And then what you do from here is you will make your substitution. So this 1 over x dx, this is just equal to du, and your ln of x, this is u. So what we're integrating is actually the integral of u du. Okay, so when we integrate this with respect to u, this becomes u squared over 2 plus c, and then put back the value of u. This is ln of x squared over 2 plus c. And then you can always check, see if what you did is correct. So you check, you say find the derivative of ln of x squared over 2 plus c. So you differentiate this. The c, when you differentiate it, that is going to be 0. So ln, the 2 will come down, so you'll have 2 ln of x over 2. Then on the inside, the derivative of ln of x, this is just 1 over x. These two cancel. You have ln of x over x, which is the question that you were asked, which is the function that you were asked to integrate over there. Okay, so we know that our calculations are correct. And number 9, integral of 1 over x squared. So here again, you do a similar substitution. You let u equal to 1 plus x. Then this means that du is equal to dx, because when you differentiate that, you'll have 1 dx, which is just dx, and then you substitute. So what you're integrating is 1 over u squared, and then you multiply this by du. Okay, then integrating this is the same as u to the power of minus 2 du. And then what we have here, this is u to the power of minus 3 divided by minus 3 plus c. Our u, this is equal to, not minus 3, sorry, minus 1 over minus 1. So you have to add a minus 1. You have to add 1 and then plus c. Now our value of u is what we have up here, 1 plus x. So you have 1 plus x to the power of minus 1 over negative 1 plus c. So then your function becomes negative 1 over 1 plus x plus c. And then as usual, if you differentiate your final solution, you should get back to the original one. Okay, then we look at number 11. The integral of the square root of x squared plus 10x plus 15 multiplied by x plus 5. This is with respect to x. Now here what you need to realize is if you differentiate what you have under the square root, you will have x plus 5. So you'll have 2x plus 10, which is just a scalar, it's a constant multiple of your x plus 5. So u is equal to x squared plus 10x plus 15, and then you differentiate, you get du. This is equal to 2x plus 10, and this is dx. So you can see what we have is x plus 5 dx. So from here I can factor 2 out. So I have du. This is equal to 2x plus 5 dx. And then I can divide by 2 on both sides. So I have half du. This is equal to x plus 5 dx. Okay, now that I have that, I can substitute this x plus 5 dx that I have over here and replace it with half du. And I will have the square root of u times half du. Okay, so this is a simple one to integrate. The half can go out, so I have half the integral of u to the power of half du. And then here what I do is half the power of u will increase by 1, so I'll have 3 over 2, and then I will also divide by 3 over 2, and then you add a constant that differentiates to 0. So doing this, what we have is half divided by 3 over 2. This is just equal to 3 in the denominator, because this 2 and that one will cancel. So I'll have u to the power of 3 over 2 over 3 plus c. And then need to remember what u is. So I have x squared plus 10x plus 15 to the power of 3 over 2 over 3 plus c. Okay, so then that is my integral. So again, you can always substitute, differentiate and see if you get back to the original question. And this one shouldn't be too difficult. If you differentiate, the 3 over 2 will come down. You'll have 2 in the denominator, and then the derivative of the inside, this is 2x plus 10. Then you can factor a 2 out, and you will see that you have exactly what we were integrating. Then number 13, the integral of dx over 1 plus 2x. Now to integrate this one, you can also use a substitution. You can say let u equal to 1 plus 2x. Then we differentiate, we say du is equal to 2 dx. And then from here, we can make dx the subject, so we divide by 2 on both sides. We have half du, this is equal to dx. So I will replace the dx with half du, and this 1 plus 2x, I'll replace it with u. So what I have here is the integral of 1 over u multiplied by half du. Okay, so this, the half can go outside. So this is just half integral of 1 over u du. And we know that when we integrate 1 over u with respect to u, we get ln of u. So this is half ln of u plus c. And then u, this is half ln u is 1 plus 2x plus c. So again, a quick differentiation of this. We see that ln of 1 plus 2x, when I differentiate it, I get 1 over 1 plus 2x multiplied by 2. The 2 will cancel with this half. Then I'll just be left with 1 over 1 plus 2x. The derivative of c is 0. Okay. 15, the integral of ln 5x over x dx. So this is like ln of x to the power of 5. So it's just the same way that we write sine power 5 of x. So what we are integrating here, this is ln of x to the power of 5 over x dx. Right, so I can see that the derivative of ln of x is 1 over x, and here I do have a 1 over x. So I can look at this as 1 over x times ln of x to the power of 5 with respect to x. So what I say is let u equal to ln of x. This means that du is equal to 1 over x dx, and then I can substitute. So this 1 over x dx, this is going to equal to du, and ln of x is equal to u. So I have the integral of u to the power of 5 du. And the integral of this, you just increase the exponent by 1 and then divide by your new exponent, and you add a c. Then ln of x is u, so I have ln of x to the power of 6 divided by 6 plus c. And again, try and differentiate. The 6 will come down. It'll cancel with this 6 over there. You'll be left with ln of x to the power of 5. Then on the inside, the derivative of ln of x is 1 over x. So you see you're back to the function you were asked to integrate. And then number 17. Integrate cos x sine x dx. So here again, a substitution. We let u equal to sine x. This means that du is equal to cos x dx. You can see the cos x with the dx together will form du, and this is just my u. So I have the integral of u du. This is u to the power of 1. When I integrate, the exponent will increase by 1, and then I divide by the new exponent. Then I add a c. Then I substitute u back. U is sine. So I have sine squared x over 2 plus c. Okay, so when I differentiate this, the 2 will come down. It will cancel with the 2 that I have over here. Then I'll have sine x. The derivative of sine x is cos x. When I multiply those two, I'll have sine x cos x, which is my original equation, my original function. Then 21. Integral of 5x cubed over 2 plus x to the power of 4 dx. Now this one, again, you can see when I differentiate that, in fact the entire denominator, I will have x to the power of 3, so that should already tell me that I should let u equal to 2 plus x to the power of 4. Okay, when I differentiate this du, this is 0 plus 4x to the power of 3 dx. But when I look at my numerator, it's 5x to the power of 3 dx instead of the 4. So what I do is I multiply both sides by a constant so that I have 5 as my coefficient. Excuse me. So here I will multiply by 5 over 4 on both sides. I have 5 over 4 du. This is 5 over 4 times 4x cubed dx. So these two will cancel like that. Then what I'm left with is 5 over 4 du, which is equal to 5x cubed dx. Okay, then this 5x cubed dx, I will replace it with 5 over 4 du. So what I have is the integral of 1 over u times 5 over 4 du. Okay, so integrating this, the 5 over 4 can go out. Then I have the integral of 1 over u du. Okay, this is 5 over 4. And then I have ln of u plus c. But then my u is 5 over 4. My u is 2 plus x to the power 4. So I have ln of 2 plus x to the power 4 plus c. Okay, so again, always good to check, quickly differentiate what you have, see if you get the original function back. Then 23, the integral of 1 plus e to the power of 2x over e to the power of x dx. So this is equal to the integral of 1 over e to the power of x dx plus the integral of e to the power of 2x over e to the power of x dx. So you can split this one up and simplify, right? So when you do that, you have the integral of e to the power of minus x dx plus the integral of e to the power of x dx. Now the integral of e to the power of minus x dx, here you can use a substitution, but it's not difficult to see because we know that when we are integrating, we're looking for the function that when we differentiate, we get e to the power of minus x. So I know that if I differentiate e to the power of minus x, my derivative will be minus e to the power of minus x. But then if I differentiate this, my answer is now positive e to the power of minus x. So that tells me what my integral of e to the power of minus x is. So here I can also use a substitution. If I let u equal to minus x, then du is equal to minus dx, and then this means that minus du is equal to dx. So what I'm actually integrating is this, e to the power of u times minus du plus the integral of e to the power of x dx. Then this is just minus e to the power of u, because when I integrate e to the power of u with respect to u, it doesn't change. And then plus e to the power of x, because e to the power of x, when you integrate it, it remains as it is when you add your constant over there. So this is equal to minus e to the power of minus x plus e to the power of x. So you can rewrite this as minus 1 over e to the power of x, e to the power of x plus e to the power of x plus c, like that. And then for the next one, this is number 27, number 25, sorry. We have the integral of dx over e to the power of 2x. Okay, so again, we can rewrite this. This is the integral of e to the power of minus 2x dx. And then we make a substitution. So we let u equal to minus 2x. This means that du is equal to minus 2 dx. And then we can say that minus half du, this is equal to dx. Then we substitute where we have dx, we will put minus half du, and then 2x, we will put u. So this is the integral of e to the power of u times minus half du. So the minus half goes out with the integral of u du. So this is minus half e to the power of u plus c. So this is minus half e to the power of u is minus 2x plus c. And then 27, the integral of x to the power of 3 sec squared x to the power of 4 dx. So another substitution, we let u equal to x to the power of 4 du. This is equal to 4x cubed dx. Can divide by 4 on both sides because I only have x cubed dx. So I have 1 over 4 du. This is equal to x cubed dx. So this is what I will substitute for x cubed dx. So when I do that, I have the integral of x squared, x to the power 4, this is u, and then I have 1 over 4 du. So the 1 over 4 can go outside the integral, and then I have sec squared u du. Okay, with this I have 1 over 4. The integral of sec squared is 10 of u plus c, and then u is x to the power of 4. So I have 1 over 4 tan of x to the power of 4 plus c. E29 is the integral of e to the power of x sec e to the power of x tan e to the power of x dx. Okay, that's a dx over there. Right, so here you can see the function sec x tan x. You should already be thinking the integral of that is going to be sec x. Now our function, we can let u equal to e to the power of x. This means that du is equal to e to the power of x dx. All right, and then from here we just substitute because we have the e to the power of x dx there already. So this is the integral of sec u tan u, and then I have du, where's my dx, du. Okay, so the integral of sec u tan u, this is just sec u, so this is sec u plus c, and this is sec u is e to the power of x plus c. Okay, that's it. So again, you can do quick differentiation. Differentiate sec, that's on the outside, you get sec e to the power of x tan e to the power of x. Then differentiate e to the power of x, you just get e to the power of x. And the derivative of the constant is 0. In 31, we have the integral of sec 2x dx. Here what we do is we multiply by a special term. Okay, this works for some functions and it works for this one as well as cosec of x. So it doesn't work for every function, but this is like a trick that we can use. Now first we will do a substitution. So we will let u equal to 2 to the power of x. This means that du is equal to 2 dx, and this means that half du is equal to dx. Okay, so when I substitute this, I have the integral of sec u multiplied by half du. So this is half the integral of sec u du. Now what I'm going to multiply by is another function which is equal to 1. So I will multiply by this half integral. So sec u, I will multiply this by sec u plus tan u over sec u plus tan u. Now the reason I multiply this is when I multiply out the numerator, I get sec squared u, and then I get sec u tan u. Okay, now if I look at that, this is all with respect to u, by the way. So when I multiply that out, this is what I get. I get half, and I get sec squared u plus sec u tan u over sec u plus tan u du. Okay, so this is what I have. Now, if I look at the numerator compared to the denominator, when I differentiate sec u, I get sec u tan u. When I differentiate tan u, I get sec squared u. So you can see that my numerator is the derivative of the numerator. So that is why I did this multiplication over there. So I introduced the derivative of a function so that I can use substitution. And now that it is in this form, I will say v now. So it's like a double substitution. And that v equal to sec u plus tan u, then dv, this is equal to sec u tan u plus sec squared u, and this is all multiplied by du. This is just in my numerator. That is the numerator as it is. So what I am actually integrating, this is just half the integral of 1 over v dv. And here, this gives me half ln of v plus c. So I unsubstitute v, so this is half ln v, this is sec u plus tan u plus c, and then I unsubstitute u, this is half, and then of u was 2x, so this is sec of 2x plus tan of 2x plus c. Okay, so this involved the double substitution, but again, if you try to differentiate this, you will notice that your answer is exactly the same. Okay, let's do one more like that. This one is number 32. If you're asked to integrate cosec x with respect to x, so here I will use that trick of introducing the derivative. So to do that, I will say cosec x multiplied by cosec x plus cot x over cosec x plus cot x, and this is all with respect to x. And when I multiply this out, I have cosec squared x plus cot x, cosec x over cosec x plus cot x. This is with respect to x. Okay, then if we look at the numerator and the denominator, again, when I differentiate cosec x, I get negative cot x cosec x. And when I differentiate cot x, I get negative cosec squared x. So the difference between the numerator and the derivative of the denominator is a constant multiple. So if I multiply the numerator by -1, I will have the derivative of the numerator, of the denominator, sorry. So I say let u equal to cosec x plus cot x. This means that du is equal to negative cosec x cot x minus cosec squared x, and this is all dx. So I'll divide by -1 on both sides, then what I have is minus du. This is equal to cosec x cot x plus cosec squared x dx. Now I'm ready to make the substitution, and when I substitute, what I have is this 1 over u multiplied by negative du. So this is just negative the integral of 1 over u du. The integral of 1 over u is ln of u. So this is negative ln of u plus c, which is just negative ln cosec x plus cot x plus c. Okay, so not too complicated. So with sec and cosec, you can always use this trick. Cot and tan, those ones you can rewrite them in terms of sine and cos. And if you let the denominator, so for example, if I ask you to integrate cot x dx, you have, this is cos x over sine x dx. So here you'll just make the substitution that u is equal to sine x, and then du is equal to cos x dx, so which is your numerator. And then with tan, the other way around, it's sine over cos, so you let your denominator equal to u, and then you'll make the substitution like that. So this is by the way. So you should be able to integrate any of the trigonometric ratios. Then look at the 34. This is the integral of dx over x squared plus x minus 2. Now with this one over here, if I were to let u equal to my denominator when I differentiate that, so we can just try it and see. Let u equal to x squared plus x minus 2, then du is equal to 2x plus 1. I do not have 2x plus 1 in my numerator, but I can substitute, this will be dx, to get rid of that and rewrite everything in terms of u. So a substitution will not work over here. So what I do instead is I'm going to use partial fractions. So my denominator, I'm going to factorize it and then decompose my fraction into its partial fractions. So what I have is this. I have 1 over x squared plus x minus 2. This is just 1 over x plus 2, x minus 1. So I factorize the denominator and then I will decompose it. I get a over x plus 2 plus b over x minus 1. So now that it's decomposed, then I will combine it and then equate the numerators. So my numerator, I have a x minus 1 plus b x plus 2. This is equal to 1. So the numerator over there is 1. Then I say x is equal to 1. So when x is equal to 1, the a disappears. So I have b 1 plus 2. This is equal to 1. This means that b is equal to 1 over 3. And then when x is equal to minus 2, when x is equal to minus 2, you can see that the b over there will disappear. Then I have a minus 2 minus 1. This is equal to 1. This means that a is equal to minus 1 over 3. Okay, then what I do from here is I will rewrite the integral. So my integral was 1 over x squared plus x minus 2 dx. So I will rewrite it in terms of its partial fractions, and what I have is negative 1 over 3 over x plus 2 dx plus 1 over 3 over x minus 1 dx. Let me see. So a was over x plus 2. Okay, that's fine. Then the negative 1 over 3 can go out. Integrate 1 over x plus 2 dx. And then you have 1 over 3, the integral of 1 over x minus 1. This is dx. So there should be a dx over there. And then what you do is you integrate this one as it is. So we know how to do that. This is just minus 1 over 3 ln of x plus 2. And then I have 1 over 3 ln of x minus 1. Okay, let's write this better. Plus 1 over 3 ln of x minus 1. And then you add your constant over there. Okay, let's do one more. Here's the integral 1 minus x squared. So this is again one that you will have to use partial fractions to decompose, because if you let u equal to your denominator, when you differentiate that, you cannot rewrite the derivatives so that u is isolated. You always have x, so you cannot make that substitution. So instead what you do is you decompose into partial fractions. So you have 1 over 1 minus x squared. When you rewrite this, this is 1 over 1 minus x, 1 plus x. And then this becomes a over 1 minus x plus b over 1 plus x. Then you know how to combine them. This is a 1 plus x plus b 1 minus x, and this is equal to 1. So this is my numerator that I'm looking at. And then we can let x equal to 1. So when x is equal to 1, this component will disappear, so b will be gone. Then I will have a 1 plus 1. This is equal to 1. This means that a is equal to a half. And then we let x equal to minus 1. This means that this component will now disappear. So you'll have b 1 minus negative 1 is equal to 1, which means that b is also equal to a half. So I have my a and b. I just substitute them and then integrate. So what I'm actually integrating is this, the integral. My a is half, and a is over 1 minus x dx plus the integral of half 1 plus x dx. So we integrate this. This is half integral of 1 over 1 minus x dx plus half the integral of 1 over 1 plus x dx. Okay, so what you do here is you now just integrate this one here. You can use substitution if you like, or if you know what it is without substitution, that's also fine. So here you can let u equal to 1 minus x, which means that du is, let me put it in red. Okay, so we have u equals to 1 minus x, du is equal to minus dx because of the negative over there, and this means that minus du is equal to dx. So what you're actually integrating over there, this is 1 over u times negative du. So this is just negative integral of 1 over u du, which is negative ln of u. Okay, so when I integrate this over here, what I will have is half negative ln of 1 minus x plus half plus half ln of 1 plus x plus c. Okay, so that's what I will have. And you can simplify it. This is minus a half ln of 1 minus x plus half, again, base, is a half ln of 1 plus x plus c. Okay, so you can always check, try and differentiate what you have over here. So you can always try and differentiate what you have gotten as your answer and see that you end up at the original question. If you've done it correctly, you should. If not, go back and look at what you have done. Maybe you missed a sign, or in changing your partial fractions, you didn't do it correctly. Okay, so there are more questions in your notes. Please go over them, and see you in the next class.